During the scale model project, students design and build a deck to fit the dimensions of a model home. First step is technical sketching. After learning how to use the architectural scale, students use the 3/4 scale to draw their scale model. Here's an example drawing. One of the major components of the project is calculating materials. Students first calculate the materials needed for the scale model and then use proportions to convert them to real-life dimensions. Students also complete a cost analysis to figure out the cost per square foot to compare to other students' models. The next step is to actually construct the model. Common construction techniques are discussed throughout this process and throughout the entire project. One of the major math concepts addressed throughout the project is the use of proportions. Students first learn how to set up a proportion in a real-world context in order to convert scale model sizes to real-life dimensions. After learning how to set up the proportion, they then solve the equation using the exact same process they practice in math class. Here's an example proportion problem using a 3/4 scale to convert a 10-inch scale dimension to a real-life size. In the physics classroom, students learn how to calculate the forces exerted on the deck's posts. This ties in the traditional physics concepts of pressure and force, while requiring students to calculate the area of their scale model. Another opportunity to tie math into the lesson is calculating the joist quantity. Here students calculate how many joists are needed for a 100-foot deck, where J equals the joist and S equals the spaces before being converted to J minus 1.
I learned how to utilize an architectural scale to engineer a deck to meet certain criteria and constraints.
I learned that you can't just build a deck on design. You have to take in force, area, and pressure. That's how science is involved in building a deck.
Practice what I learned in math class in a real-world environment.
And I learned how to use proportions and equations.
We do a lot of math in STEM.